Hello chicos, today we're going to do lesson 8. Very easy, area of different figures, different shapes. So remember, area is the surface inside the perimeter. And we have here different formulas that you have learned in the past. Remember, for the first one, the square, we are just going to multiply one side by the other one. So side square. So that's why the formula is that. Then we have for the rectangle, length times width, which is the 2 dimensions of the rectangle. For the triangle, remember that is the base times the height divided by 2. And remember that the height is always perpendicular to the base. For the circle, we have radius squared pi. And for the semicircle, which is half of a circle, radius squared pi divided by 2. So let's look at this example 8.1. Notice that it's not one of the shapes on the top, but if we divide it either here or, and that would be like 2 rectangles, or if I divide it in the other way, if I divide it here, I also get 2 rectangles. So you guys can choose whichever you want. I'm going to do this one that I have right now. So notice I'm going to have to find the area of the first rectangle and then add the area of the second rectangle. So this is the 1 and the 2. So we have to look for what are the dimensions of each one of those rectangles. The dimensions for this rectangle is 2 by 5. I don't need the 3 anymore. So 2 by 5. And then the dimensions of the other one, we're going to notice out here we cut the 6. So this 6 doesn't really exist in a way anymore, like we don't need it. We're just going to use 4 by 2. And then I just multiply and add. And the area of that L shape is going to be 16. Remember always your units square. In this next exercise, example 8.2, what they give us is a big rectangle that then we cut out another smaller rectangle from it. So notice that what is happening is there's going to be a hole in this part here. So what you're going to do to find the area of the shaded portion is we're going to find the area of the big one, and then we're going to subtract the small one. Very, very simple. And the dimensions are there, 10 by 8 for the big one and 6 by 2 for the small one. So in this case, it's going to be 80 minus 12, which is 68. In example 8.3, they asked to find the area of these 3 triangles. But notice that they all have the same base and the same height. So what we have to realize is that the area of all 3 is going to be the same because the formula is the same, base times height divided by 2. The point of this exercise is for you to see what is the base and what is the height whenever we have a right triangle, or what is the base and what is the height if we have a obtuse triangle. Notice how the obtuse triangle has the height outside and is an imaginary line. It is not an actual line from the triangle. And then for an acute triangle, here is the base and again an imaginary line for the height. So in this case, the area of all 3 triangles is going to be 3 by 4 divided by 2, which is 6. I'm putting meters, square meters in all of them because I don't have the specific unit, but that works just fine. Example 8.4, it's another easy exercise. Notice that we have a triangle and we just have to use the formula. Now the thing is, which side are we going to use for the base and the height? Now what we have to see is that this is a right triangle. So since it is a right triangle, this would be the base and this would be the height. So we just have to multiply 6 by 8 divided by 2. Now the 10 is not necessary, so we don't have to use it. In example 8.5, they give us a trapezoid. And so what we need to do is, there are 2 ways we can do it. We can divide it here and we'll find the area of the rectangle, which is 6 by 4. And then the area of the triangle, which we need to find this, and that's 10 minus 6, 4, and a 4 here also. So the area in that case, if we do it by that, it's going to be 6 by 4 for the rectangle plus 4 by 4 divided by 2. And that is 24 plus 8, 32. So that's an easy exercise. We just divide the trapezoid into a rectangle or triangle. But we could also use the formula for trapezoid that we haven't seen in this video. But the formula for a trapezoid is the big base plus the small base times the height divided by 2. So let's see what each one of these things is in the drawing. The big base is the long base here. The small base, it's going to be parallel to the big base, and is this other one here. Then the height is the distance between the two bases, so that would be the height. So let's use the formula and see what we get. So in this case, we have to add the two bases, 10 plus 6, and multiply times the height divided by 2. If we do that, that's going to be 16. We cancel these 2, that's going to be 2. So 16 times 2, which is 32 square meters again. So you have the choice. You can either do the division of the shapes and then get a rectangle and a triangle, or you can memorize this formula and or have it in your formula sheet and use that, which is a lot easier. Example 8.6, it says the radius of a circle is 3. Find the area. So remember, it's very easy. We just use the formula radius square pi. And in this case, the radius is 3, so 3 square pi, which is 9 pi. And that's all we have to do. In this case, we do have the units, so it's square centimeters. Remember, area is 2 dimensions, so we always put the units square. In example 8.7, we have the area of a circle. So they give us the area of the circle, which is 36 pi. Since we want to find the radius, then we use the formula, radius squared pi, and we solve for r. So what does that mean? We need to leave r by itself. So I'm going to pass the pi to divide. So 36 pi divided by pi, that's going to be r squared. We can cancel the r's. And then 36 equals r squared. To find the answer, we have to get the square root from both sides, and 6 is going to be r. So the radius is 6. Okay, very good. In example 8.8, they asked to find the area in inches. And again, we have a very complex figure, but that we can simplify by cutting here into shapes that we know. So we're going to have the area of a triangle plus the area of a rectangle plus the area of a semicircle. All right, so we just have to use our formulas that we have from the first page. And remember again that this 7 is all of these. So we're going to have to find what is this part here. So we subtract 7 minus 5, which is 2. We also have to find what is this length, which is 2 radii, because notice this is 2 and this is 2. So that's 4, so this is also 4. So now we put our formulas, and we have base times height divided by 2. We have length times width, and we have r squared pi divided by 2. Now we just have to substitute the given values and find the answer. So it's going to be 2 by 4 divided by 2. Then this other one is going to be 5 by 4. And then the semicircle is going to be 2 squared, which is the radius, pi divided by 2. So in this case, we have 4 plus 20 plus 2 pi. Now remember, we only add the like terms. So in this case, it's going to be 24 plus 2 pi. And it says that the area is in inches, so square inches. In example 8.9, what they're asking is that we find the area of this parallelogram. And again, we haven't seen this formula in this video, but it's very, very easy. So the area of a parallelogram is base times height, just like a rectangle. Length times width, base times height. Now, we have to remember that a height is always perpendicular. So, in this case, if this is the base, the 8 is the base, then the height is going to be 4. Okay? Because 4 is perpendicular to 8. And so in this case, the area of this parallelogram is 8 by 4, which is 32. Now notice again, we don't use the 5 because the 5 is just another side. We don't use it for area. In this last example, example 8.10, we have to find the area of this trapezoid. And again, I already shared with you the formula for trapezoid. So we're going to do the big base plus the small base times the height divided by 2. Notice how I use a lowercase h because we're talking about the height of a two-dimensional figure. Whenever we have a solid and we're talking about the height of a solid, then we use capital H. So in this case, if I substitute in this formula, we're going to do 15 plus 9 times 4, which is the height, divided by 2. And again, notice that we don't use the 5s. So in this case, 15 plus 9 is 24. And 24 times 2, if we cancel this, is 48. And in this one, they do say it's in meters, so square meters. That's it, chicos. So now do your practice and let me know if you have any questions. Good job.